This tutorial covers an area of common concern about cultured pearls. Specifically, are they real? You will find that with a little practice that this is actually a fairly easy skill to acquire. Queen Elizabeth loved natural pearls. In addition to the jewelry she wore, it was also the fashion to have them sewn into garments and elaborate headdresses. This fashion craze, coupled with the difficulty in finding and harvesting natural pearls, actually created a shortage of pearls. Queen Elizabeth was said to have artificial pearls sewn into her garments right alongside of real pearls. Many years after Queen Elizabeth's reign, in about 1656, Moise Joachim, a bead manufacturer in Paris, invented a process to make imitation pearls. It is said that the idea came to him when he observed a bowl of water that had been used to clean fish. The leftover water had a silvery film floating on the surface. The original formula involved a hollow glass bead. Essence d'Orient, a compound made from fish scales, was blown into the interior walls of the glass bead. To hold it in place, a mixture of gum arabic was then forced into the bead. The glass displayed dispersion, or rainbow colors, like a prism, when light shined on it, somewhat imitating the orient of a pearl. This process was used by bead manufacturers throughout the 19th century and is primarily found in antique jewelry. The rendering is from Harper's Young People's Magazine, dated July 20th, 1880. According to company records, Majorca pearls were developed in 1890. Majorca pearls employ a process using a solid glass bead coating the outside with their version of Essence d'Orient. Using powdered mother of pearl from the shell lining mixed with resin, now using synthetic resin, creating a surface that resembles overtone and orient. These imitation pearls were aggressively marketed in the 1950s and 60s as a gift with purchase promotion. You would receive one pearl with your qualifying purchase, ceremoniously packaged. Once you had enough pearls, the completer kits with thread, needles, and a clasp could be purchased, enabling the buyer to complete the strand. The promotion was so successful that many people still believe that Majorca pearls are real cultured pearls. More recently, to comply with FTC regulations, marketers have added the letter I in their name to create the trademark Majorica instead of Majorca. FTC regulations are covered in a later tutorial. Likely influenced by the early success of Majorca imitation pearls, this early 20th century patent suggests a better way to make imitation pearls. The inventor used a silver-plated copper shell and coated the bead with colored celluloid varnish. In any event, this suggests additional support that the transition from coating the inside to the outside of an imitation pearl occurs somewhere in the late 19th to early 20th century. We saw earlier that Majorca imitation pearls are mounted on temporary posts, sometimes temporary strands, and dipped. Note the residue where the bead meets the post. Compare it to a close-up image of an imitation pearl. The accumulation at the drill hole is called puddling at the drill hole. Sometimes the edges are ragged when pulled away from the post. When comparing this drill hole to a cultured pearl drill hole, we see immediately that the cultured pearl drill hole is clean and sharp. Although not a definitive test, overtone is an indication that a pearl is either natural or cultured and not imitation. Although poor quality cultured pearls may exhibit little or no overtone. As you observe overtone, look for variations along the strand. While pearls are matched for body color, they will rarely, if ever, have the exact same overtone. Note the overtone and strength of overtone in the top row of pearls, featuring rosé, green, and some with both rosé and green overtones. The imitation strand on the bottom shows no variation in overtone. As we saw in the Pearl Value Factors tutorial, the bead nucleus of a thin nacred pearl is sometimes visible through the nacre. The images on the right were photographed with a light source from behind them to enhance the visibility of those lines. So while this is an indication of a thin nacred pearl, it also distinguishes them from imitation pearls which do not use bead nucleus created from freshwater mussels. Even though some pearls may be clean, bumps, welts, and other raised blemishes are an indication that the pearls are natural or cultured, not imitation. As the mollusk forms a pearl, nacre grows in layers of calcium carbonate. This is followed by an organic layer, then another layer of calcium carbonate. These alternating layers grow concentrically, with the process repeating until the pearl is fully formed and harvested. The growth pattern of the calcium carbonate is what makes the pearl feel gritty when rubbed against your tooth. The final image shows a Tahitian cultured pearl magnified 64 times. It is easy to see why those layers would have a coarse feel against the tooth. Because of the way nacre forms, cultured pearls will be visually different from imitation pearls. Since they are dipped, the surface of an imitation pearl has a coarse appearance, much like a layer of paint on drywall. Even though the cultured pearl feels gritty, its appearance is smooth and lustrous. Cultured and natural pearls fluoresce under long-wave blacklight. Cultured pearls fluoresce more strongly than natural pearls. Also, thick nacred pearls will not fluoresce as strongly as thin nacred pearls. When observing fluorescence in pearls, note that the pearls appear to glow like a full moon, as shown in the top row of the image at the top right. The bottom row in the same image is of imitation pearls merely reflecting the purple light of the long-wave blacklight. The image at the bottom left shows both strands under normal lighting. There are other more technical tests that can be used to tell the difference between cultured pearls and imitation pearls. Gemologists often use refractive index to identify gems. Refractometers measure the way a substance bends light. So the refractive index of pearl is between 1.53 to 1.686 on a refractometer. The birefringence or variance is plus or minus 0.15. Refractive index of a Majorca pearl is only 1.48. There is also microradiography. Pearls can be submitted to the GIA lab for a new kind of X-ray. This may be more appropriate if you believe the pearls may be natural. A low-cost alternative may be to ask your dentist to take an X-ray. You can fit 2 to 4 suspect pearls in one dental exposure. As we have seen, most identification can be made with visual inspection, known as sight ID. There are also some subjective tests. If the clasp, for example, is plated, is base metal, or silver, one should be suspicious. If the pearls are not knotted, one should be suspicious, and especially price. If it's too cheap and too good to be true, be suspicious. Although this is not necessarily helpful in the secondary market like estate sales or auctions, it's very telling. These subjective tests would also be helpful if you were trying to determine whether or not you had a dyed strand of inexpensive freshwater cultured pearls or Tahitian cultured pearls. Pearl treatments are covered in a later tutorial. Imitation pearl identification can be summarized as follows. Puddling at the drill hole versus the clean drill hole of a cultured pearl. No variation or presence of overtone. Ragged drill hole versus the clean drill hole of a cultured pearl. Stripes of the muscle bead nucleus not visible with strong backlighting. Now, thick nacred cultured pearls and natural pearls are the exception to this rule. Matte finish of imitation pearls versus the lustrous finish of cultured pearls. Smooth finish when rubbed against a real tooth. No raised blemishes. No fluorescence. Refractive index or microradiography. And subjective tests involving the quality of the clasp and the knotting of the pearls. Always try to establish identification with at least 2 confirming tests. This concludes the imitation pearl tutorial.